With great data comes even greater access latency. Welcome to the Trino Community Broadcast, where we transform your latency woes into fast insights. Trino Community Broadcast is a show where we cover events and happenings within the open source Trino community and show off some really cool stuff about views in Trino today. So welcome, Anjali. Thank you very much for joining us today. Anjali comes from Netflix, and you've been pretty active in the open source Trino community, especially very recently.
That's right. It's great to be here. Thank you, Brian.
Yes.
And it's exciting to work with all these cool things in Trino.
Awesome. And we also have yet again this week, as of last week, Martine joining us again. So thanks for joining us, Martine.
Thank you, Brian. It's good to be here again.
And my typical partner in crime, Manfred. Welcome.
Hey, everyone. And of course, we're sporting Commander Banban again, so we're ready to roll.
That's right. So actually, yeah, Anjali, now that just made me think we need to get you some Commander Bun Bun swag here shortly. But maybe if you get it by default. By the way, just a kind of a public service announcement for anybody in the community. If you join our meetups, we have monthly meetups that we're at least regularly doing in the Americas for now, and we're actively trying to extend these out to EMEA and APAC areas as well. But if you join up one of these meetups, you get some free Commander Bun Bun swag, and this is the one place we're kind of filtering out. I've gotten a couple questions down the line saying, like, where can we buy Commander Bun Bun swag? And we're not, we don't have it in a store yet, but we eventually will. But for the time being, the way you get Commander Bun Bun swag is to show up to our meetups, and then we'll set up a little thing that you can sign up and put your t-shirt size in and all that stuff. So that's just a little PSA in general, but yeah, we definitely need to get you some CBB swag and get you all set up over there, Anjali, because yeah, you've definitely done a lot for the community. We want to at least give you a shirt.
Thank you. I love Commander Bun Bun, by the way.
Good. Yeah, I was gonna say, like, he's been pretty popular, but I don't know. We need to think of a cool way to integrate him into the Netflix logo. So before we jump too heavy into what we're covering today, let's go do a quick word from our sponsor, Starburst, and we'll be back in just a moment.
As we all know, data is the lingua franca of a successful business. And the key to success for any company is deriving business value from data in a robust, scalable, and timely fashion. I am thrilled to be bringing you Starburst Galaxy because it is the solution to the problems our data teams have faced for years. This product will bring the power of Starburst Enterprise to everyone so that the path from data source to data analysis shrinks down to zero. With modern and secure managed infrastructure, we handle all the hard parts and let your data teams focus on the data itself. Because the underlying engine is Starburst Enterprise, and Starburst Galaxy gives you all the benefits of managed infrastructure, you can set up a Starburst environment and be analyzing your data in just a fraction of the time. So to sum up, with Starburst Galaxy, you get a managed data platform that connects directly to your data sources, and within our application, you can both explore and gain insights into your data. This is the next generation of data, and the ultimate platform for fast, direct value from your data.
Yeah, so actually, we're going to be updating that little advertisement to something a little more informal and on the next one. So, but we'll still have Colleen be joining us for that and get us a little bit of background into Starburst. So I know we got some commentary on our advertisements, and we want them to be a little more spontaneous and kind of more show host talking style. So look forward to that in the coming episodes. So this week we're talking about Trino views, Hive views, materialized views versus logical views, and there's a lot of times where and I should say even very recently coming into this episode where I've been confused by how views are actually like stored, maintained, and particularly in Trino, because Trino, depending on the connector, is going to have different ways that it stores a view and how it actually uses the views. And so it was always a little bit fuzzy for me, and I never particularly used it in production myself. Any views in my own experiences. So I always kind of knew what views were roughly doing, but I didn't actually know specifically, like if you're dealing with the Hive connector, or if you're dealing with like old views that were created in Hive, like how are all these things different? And so we jumped into talking about kind of some of Angeli's more recent work that you've been doing, and it's pretty cool that we're now able to do this materialized views in Iceberg. But I wanted to kind of take a little bit of a step back and to kind of actually bring us in before we just start talking immediately about like Iceberg views and start just jumping straight into the meat of the subject. There's a lot of people that are probably like me. Manfred also had a couple questions along the way too. It's just like, we're not really sure exactly how to conceptualize views as a whole when it comes to specifically, in Trino. So, Angeli, I'm going to go here into the code scene and actually just kind of bring up, we have a couple of these concepts that we'd like to talk about, views in general. Could we just take a step all the way back to maybe something that maybe a lot of the engineers will at least know, or at least most people in this community will be able to understand, which is starting with table abstractions and then maybe move towards, actually talking about views from there. Like, how are tables that we know pretty well that have all these columns and data, how does that ultimately become a view, or how are they even related to views?
So first, let's think about why views are even necessary. I think views provide 2 or 3 distinct benefits. One is you can hide data from the end user. You can put all your complexity inside the view and provide literally an abstraction over the underlying data, which makes it easier for the end user because they're not worried about, hey, how is this calculation performed? All they need to know is, hey, this is sum of sales amount. That's all they need to know. They don't need to know exactly which function was used to compute that.
Yeah.
So views are really a mechanism that let you build an abstraction layer on top of your tables, on top of your data. They can contain all kinds of SQL complexity like joins, aggregations, groupings, so on and so forth. Essentially, that's what it is. It's a view of the data, and
Okay.
you can build many different views over the same data, giving different roles, different types of accesses, different types of abstractions over the same data. A salesperson might be interested in looking at a certain dimension, a marketing person might look at a different dimension, and so on and so forth.
So you can
That's
actually...
what the first confusion always comes up with me. Like I'm coming from a relational database background, I do a create table, all is hunky-dory do, and it gets stored in the database. I go and do a create view, and everything is hunky-dory do. I understand what's going on, and it got stored in a database, and everything is good. And now I'm Trino, I'm seeing create table, and I'm like, where does the create view, where does the view even go?
We don't store data.
Yeah, so I'm like, whoops, it's there, but it's not. So what's going on, Martin? Maybe can you explain what's happening?
Yeah, so if you think about it, so in SQL, views and tables views and tables are like similar entities. Like they have a schema, they have a set of columns, a set of data types, and to the engine and to anyone querying them, they really appear as if they were just regular tables. You can think of a view as is like a promise to compute some data at some point. So from the user's perspective, they just type a query like they would be querying any other table. Select start from something, and that something can be a table, can be a view, and so they both exist in the same table namespace, if you will. So the way Trino deals with them. There are two APIs in the connector interface. One for obtaining information about a table, which is basically the engine tells the connector, give me the schema definition of a table, and there's a set of physical properties that are associated with a table. And then for a view, you can say, give me the query definition of this view plus all the schema, the tables, the columns and types. And then it's up to the connector to decide where to store that definition. Just like For example, if you're querying the Hive connector and you ask for a table, it will consult the metastore and say, well, what is the schema of this table? What is the location? Is the location in S3? Is in HDFS? And then it goes on after that. For a view, is the same. It will say, well, what is the definition of this view? And the connector will have to say, well, I need to go to some place that has that definition stored. In the case of Hive, it will be the metastore, because the metastore understands how to store views. In the case of some other connector, it might be a different thing. Like if you're talking to, in Trino, not many connectors support views today, but if you were to implement a connector, for example, a connector that is based on making API calls to a remote service, you might have an API call that the remote service implements that provides that definition of a view. So all you need is for the connector to be able to store that definition somewhere and then produce it on demand when the engine asks for it.
So the typical behavior with, say, the PostgreSQL connector is that a table just shows up as a view and you create it in Postgres, or can you create it in Trino at the stage already as well?
This is one thing we need to separate. So when you're talking about Postgres tables and views, those are presented to Trino as if they were tables. Like these are, so Trino talks to, the Trino Postgres connector talks to the Postgres instance and issues SQL queries via JDBC. And for a JDBC connection, a table or a view inside Postgres appears as a regular table. Just like for an end user, a table or view inside Trino appears as a regular table for the purpose of querying. So Trino doesn't know that there's a view inside Postgres. It just interacts with them as if they were tables, and then Postgres on the fly will compute the results of the view. Now, if you wanted to have views inside, if you wanted to support Trino views and store them inside Postgres, you would need to, the connector would need to be smart enough to be able to store those views in some sidecar table or some other storage. So the connector
so it
doesn't
wouldn't create a native, like, so currently you can't go create view with a Postgres connector and it creates something in Postgres. It just doesn't.
Correct. It doesn't work that way. Yeah.
Okay. So you'll create it natively.
It might be possible to extend the connector at some point to do that, but that's not currently possible.
So for today's discussion, it's really important to keep this in mind, that what we are talking about are Trino views and Trino materialized views built on top of tables that can be from any connector, or views for that matter on top of any connector.
Yeah, so I actually went and focusing on kind of Trino specific views, we kind of rule out most of the connectors that generally exist across the board with Trino, except for this is kind of like dealing with the Hive connector and the Iceberg connector. So if we let me just bring this back. I pulled up basically this little table that was created basically just to summarize the ways in which we have Trino views, and some of which like we currently don't have the capability to support. So originally, I believe the kind of initial request for views was actually coming in from Hive, right? Like I'm migrating from Hive and I'm moving to Trino, and I need there to be a way that from Trino I can access these views, at least to kind of maintain my operations moving forward, and maybe at some point migrate those views or the data that's sitting in those views over into something that was maybe created by Trino. So what was initially, and I don't exactly know the timeline, so maybe Trino views existed before this ability to read Hive. Is probably actually the case, but let's just, for the sake of the conversation, let's start with views that were created in Hive, and then we now need this ability to actually read those views out. So how do we actually go ahead and read those views? There's kind of an issue, and Anjali, can you tell me a little bit about the issue that if I create a view in Hive, is there, or maybe this may be something more closer to Martine's area, but either of you, if I create a view in Hive, like what are some of the challenges that lie in terms of like storing that view and pulling it back out? So there's a view that was created in Hive, and now I want to read it from Trino. What does that what does the shape of that look like, and what are some of the challenges to actually implementing that?
Yeah. So one thing to understand is that the definition of a view as Trino expects it is a SQL query, right? So when you say create view and you provide a query, what Trino communicates to the connector is this is the query, the query using the Trino SQL language that's associated with that view. And then when you ask the connector, give me the definition of a view, it expects a SQL definition that is based on Trino SQL language. Hive has its own concept of views and uses the Hive dialect of SQL. It's called HQL. And when you create a view in Hive, you say something like create view as, and you specify a Hive dialect query. It gets stored in the metastore in a textual form using that Hive dialect. So obviously that's not compatible with Trino. You can't the connector. So if the connector took that HQL view and returned the text to Trino, Trino wouldn't know what to do with it. It has different syntax. There are functions that exist in Hive that don't exist in Trino. Some of the operations have different semantics. So if you try to execute that HQL query as part of a query in Trino, that just wouldn't work. So what you need there is for the connector to adapt the definition that's in using the HQL to something that Trino can understand. And I think that's where you were going to go with what needs to happen. So there's a translation layer in the middle. So when Trino says, I want the definition for this view, the Hive connector consults the metastore and says, is there a view stored in the metastore, and is it HQL? If it is, then translate it to something that Trino understands before returning it to the engine.
Yeah, and so to do that, this was implemented, I think, a while back. I put an honorable mention to the PR that integrated this, but there's this library that LinkedIn created called Coral. Could you tell us, again, this is all up for Anjali or Martine, but maybe Martine, I'm not sure if you know more about this, but what is Coral actually like doing or taking care of with this translation layer? Like, how does it work?
Yeah, Coral is a library that takes one dialect of SQL, like it parses it, does all the analysis. So basically, when you do translation, you can do translation at the syntactic level, but that may miss a number of things. Like you may not understand the semantics of some operations. Like some combinations of operations may produce one result in one dialect and a different result in a different dialect. So you cannot do a simple syntactic translation. You have to understand types and things that are not immediately obvious from looking at the SQL in order to do a proper translation. So what Coral does is it takes the query in one dialect, it parses it, does the analysis, converts it to an internal representation, and then reverses that into a different dialect. And obviously, at that point, it applies rules that say, well, if I have a combination of this function call with something else in the other dialect, that translates into this other function or this other structure. So it does the translation and then produces the corresponding SQL in the target language. And for that uses
Oh, sorry. Go finish what you were going to say.
No, I was going to say for that uses this optimizer framework called Apache Calcite, which has parsers for different languages. It has an intermediate representation. It has facilities for transforming that intermediate representation from one shape to another by applying a set of rules.
So basically, Coral is actually taking this Calcite library and it's pretty well known and pretty well used in a lot of different various query engine and database projects. It takes that and just kind of applies it to Metastore specific, like Hive Metastore specific dialects that utilize Hive Metastore, I think is the main gist. And I might be totally misrepresenting that, but I think that's the basic gist, is that that's what Coral's add is on top of what Apache Calcite already offers. So there's an image that we have kind of embedded in the show notes, and it shows an example of this where, you start out with this Hive query, then Coral will basically take that Hive query and do the analyzing and shows kind of an example representation of what the query might look like in an internal intermediate representation. And then it translates that intermediate representation with a couple rules to what they call a Trino IR, a specific maybe a couple rules that get applied that make it specific to Trino's language. And then you ultimately can move from that internal representation to generate the Trino query language, and so or Trino syntax. And at that point, so if we look at kind of where what this looks like, I've also added a sequence diagram. So if we look at again, so if you're on the podcast, definitely check out the show notes, because we have a couple diagrams here to kind of help conceptualize what's actually going on here between the different systems. So in the beginning, you started out with Hive, and so you'll start from the Hive system and basically create the Hive view. And this is talking about, we're going to get into this here in a second, but this is just talking about a logical view and not necessarily a materialized view that's going to persist any data. So we'll basically create a logical store, essentially that Hive QL create view language and store the query that gets run anytime you address that logical view. And then it basically just says, okay, this view is created and you can start querying it, do whatever. But then to call it from Trino, you actually say, okay, if I'm going to select, query this Hive view now, I need to actually, I'll go and fetch the metadata, but what comes back instead of this Trino syntax query language that defines this view, it's actually, as Martin had kind of mentioned, is going to be in this Hive syntax. So we need to perform this translation layer after it comes back from the metadata using Coral before we actually move that back to the query engine in Trino to generate the plan and actually go forward and retrieving the data. So that's what this sequence diagram here is showing from top to bottom in plain English. That actually kind of provides a really cool segue, I think, for us to move into talking about the next subject. So we've talked a little bit about logical views, but what is kind of the difference between a logical view and a materialized view? And I'll direct that one to Anjali.
So logical views don't store any data, right? So you have the tables, you have the logical views, but logical views don't have any data. At the same time, users are like, hey, I have this cool encapsulation of over this data. But every time I write a query against this logical view, the engine is going to go take the view definition, expand it out, and run that query against whatever was the base table. Now, depending on what is in that logical view, it can be expensive. Now, on the other hand, it would be cool if you could actually pre-execute that logical view definition, that query, and store the result somewhere.
And then basically what you would avoid is you avoid all the aggregation and any of the complex calculations and whatever to create the data, right? Because otherwise, right, if I run a query into a logical view and then Martin runs the same query, it has to do that aggregation each time. Versus with the materialized view, it doesn't, right? So
it doesn't. Way more the materialized view stores this data. So essentially, you can think of materialized view as a combination of table and a view. It's a table because it holds some data. It's a view because it has a definition associated with it. So materialized view essentially says, here is my definition, and here is the data corresponding to that definition. So it's kind of a concept that uses both tables and views.
Okay. And we were, you mentioned a little bit before too, I didn't want to miss this. There's also, so, we have these views that kind of hide abstractions at the very least. Now we have this kind of secondary use case where, okay, we're going to be repeatedly calling this view. So we want to make sure that we're storing that data somewhere so that we don't have to keep recalculating it. But there's also like another use case that people use views for, which is like, authentication and trying to verify, basically hide different things that maybe low level tables that you don't want certain users or certain departments or roles to have access to. So could you go into a little bit of that use case and talk about that in terms of views?
So views as well as materialized views allow you to do this, where depending on your definition, you could project out certain columns, sensitive personal information type columns. You could also filter out rows that are not relevant to the role of the user and give the users access only to the logical view or the materialized view without giving any access to the underlying base data.
So there's almost kind of a way, one way that, there's all this stuff about like, you want to mask, there's like a attribute masking and row masking and things like that. That still returns the row, and you can actually perform queries on the row. But this one would actually say, okay, they're not going to need to know about this column, or maybe this is some complexity that I'm trying to hide, or maybe I just don't want this person or team to have access to this data at all, not even to even use it within the query. So I am going to totally hide this, and this is kind of taking it that step further and kind of hiding or keeping that data away from people who don't need to see it.
That's right.
Cool. Very cool. And there's in Trino, there are these concepts of a definer and invoker. Is that kind of one of the ways that you can also kind of specify this language to say who actually can run these views or have access to these views?
I can take that.
Yeah.
So the SQL specification talks about views as executing with the privileges of the person that owns the view. So for example, if you, Ryan, go and create a view that selects from, an employees table, and then someone goes and queries your view, that query that's part of the definition of the view will execute with your permissions, which is, and this is super powerful because it means that you can grant restricted access to that underlying employees table to everyone else but yourself. And then you can present only the piece of data that are that you want your end users to see. Like for example, if you have, let's say your employees table has a social security number, and you want people to be able to query the names of the employees but not access their social security number, you can hide that column and you can restrict access to the underlying table, but give access to the view. So when people query that view, they can get the names and any other details, but they can't. There's no way for them to go and get the social security number.
Got it. Right.
So that's what's called definer security mode, and that's what's covered by the specification, the SQL specification. We added an extension to this model by introducing another security mode, which we call invoker. And this is a kind of a way to treat views as templates. It's like if you wanted to treat your view as a stored query, just because you want to save from the trouble of having to type that query over and over again, but you want the query to execute with the permissions of the person querying the view, then you use the invoker. So basically, it says it doesn't matter what the permissions of the creator of the view are. The definition of the view is going to be expanded into the query that refers to it, and then it will apply the rules of whoever is executing that end query. Okay. So, for example, if that view was set up to access the employees table, and you referred to some column that the user didn't have permission to, or even access to the table that didn't have permissions to, then if Manfred goes and queries your view, he will get a permissions error because he doesn't have permission to the underlying tables.
Okay.
So they kind of serve two different use cases.
Yeah.
As I said, one of them is just a way to conveniently define stored queries that people can reuse. In the other case, you're trying to create an abstraction over data and permissions and so on by hiding the underlying physical tables.
Yeah, I like that that analogy you draw on the invoker one, which is more of like a template and just kind of reusing it, and each individual person that comes in, you're not sure if you're going to have the permissions, but you can at least give it a shot to try to rerun the same query that somebody else is running. So that's good. Makes sense. Okay, so then getting back to this, again, check this in your show notes if you're listening to this, but we have this table here. So we've talked about Hive created views, and so far we've touched upon the logical view and how you can read those out. And so now that we've kind of touched into like the materialized view of Hive created view, this is also something that's possible to accomplish from Trino. And it works roughly the same way. The difference this time, though, is when Hive creates this view, the only thing is that when you create the view, you actually are storing data in your data store. In this case, we're showing it as min.io. This could be HDFS or whatever data store that you're using. And you create the materialized view. You essentially, let's think of it like a CTAS. You move the data over, and then that data has been moved over, and then you store the viewed information inside of the meta store, and then that goes as the materialized view is successful. So you're also able to actually view these materialized views just like you could view logical views. The flow is pretty much the same after that. You go to query that table, you get that metadata, and you still get Hive QL back. So again, we're going to need Coral to run this translation, and before we actually pass that back to the Trino query engine to run the plan and ultimately retrieve the data for the materialized view. So both, if you have Hive tables that exist logical views or materialized views that were created in Hive, and now you're moving over to Trino and you want to read those views, that is totally something you can do. The one caveat is that it is a read-only setup here. So the idea is really for migration into kind of if you're trying to update or refresh those views, you're not going to have that capability like you would in Trino with the Trino.
Yeah, exactly. I was just going to mention also, this is really just a helper for people that have Hive views, like from a legacy perspective, or have some other tooling where Hive views are still very much used. Because like as great as Coral is, and as much this is an amazing feat to have all these translation layers, it is a translation layer, right? Yep. So there's always going to be edge cases and corner cases that are not ideal, and you have to deal with the complexity of understanding how to even write these Hive QL versus proper SQL queries in Trino. So I think what Anjali and Martina have done recently with the Trino views, that's where it gets truly interesting. And I think that's what we want to talk about now. I think that's the amazing side of things. This is more like, we support this. This is like a legacy thing. Let's do the right thing.
Yep. So now getting to the Trino views, when we look at this whole grid of logical versus materialized and which connector we're working on, so as we kind of mentioned before, Hive and Iceberg are the ones that we're really utilizing our own definitions and our own code to store and pull and update these views. So these are the ones that actually require a lot of our own system or particularly Trino to manage these, versus the other ones like Postgres, MySQL. Again, those are all just for the time being, the way that it's set up in the connector. Those are all getting passed up to as basically being shown as tables. So Hive and Iceberg are the two connectors that we're looking at, and we in Hive we're currently only able to create logical views, and the big change that we're talking about today in today's PR of the week that we'll cover here in a second is the materialized views that in Iceberg that Anjali added. So first, let's just touch real fast on what we're able to do in the Hive connector by doing the by just kind of talking through what this sequence will actually look like. So as we mentioned before, now that we're in Trino land, every view that we create is already in the Trino syntax. So we no longer need the Coral library. So we're basically going to create the Trino view. This is going to store that Trino query in the Trino syntax in the Hive metastore, and then we get a success, and now we can actually query that view and pull that data from the metadata, and we no longer have to do this translation step. This goes directly back to the query engine. We run the plan, and we pull the data out. And again, this is a logical view, so this is actually going to execute the query internally every single time. So this is the Hive connector. Hive connector does not support doing materialized views. Now, up until this time, this more recent PR, Anjali, can you talk to us a little bit about materialized views in the Iceberg connector, and kind of talk about some of the challenges there? I think this is really what we're really interested in hearing about today, and kind of what some of the development challenges were, as well as kind of like implementation details that got a little hairy.
Sure. So materialized views don't need to be isolated just to Iceberg connector. We just decided to start out with Iceberg because at Netflix, a lot of our data is in Iceberg format. So there is the engine side implementation that added commands to create materialized views, drop materialized views, and a new materialized view specific thing, which is the refresh materialized view. So what happens when you create a materialized view is essentially you're saying that this materialized view is computed using this SQL definition. Say my MV is created as select star from base table where date range is last 90 days, something like that. So when you say create materialized view, all that happens is this object is created in the meta store, and it looks similar to the view object, except with a special indication that this is a materialized view.
Mm.
At this point, if you try to write a query against this materialized view, it doesn't have any data. So it's going to say, hey, there is no data that's cached for this materialized view. So engine is going to have to expand the definition like it does for a logical view and go execute the definition query. That is select star from that base table where date range was last 90 days. Now comes this new command. It's called refresh materialized view. Refresh materialized view essentially says, evaluate that query definition and store that data in the materialized view. Once that happens, the materialized view can be said to be fresh. It's fresh with respect to the underlying base table. Now, if you issued a select query, select star from this materialized view, engine can establish that this is latest data, and query can be served from the materialized view. It doesn't need to go to the base table, doesn't need to expand the view definition, and so on and so forth. And drop materialized view is pretty similar to a drop view command, which destroys the view object as well as drops the associated storage, associated data. So really the challenge is you can do so much with materialized views. The challenge is to figure out where to start. And what I worked with Martin and David pretty closely on this work. And what we decided is we want to get first MVP, some simple implementation with basic syntax, and we can add on top of that as we go along. So some of the interesting things really come around refresh, like how should the refresh happen? Should it be automatic? As soon as base data changes, should the engine detect that and refresh the materialized view? Or should it be triggered by a user? How exactly do you populate the data in the materialized view? So some of the interesting design challenges were along the refresh command.
Yeah, because I imagine if you are over optimistic on trying to constantly keep that data fresh and maintained, that's you rerun the entire query, I assume, or is there some way to kind of figure out a delta, and maybe specifically is it different with Iceberg versus Hive to be able to implement something like that, where you could actually see, like, because in Iceberg, right, there's ways to kind of maybe do that kind of delta or that change where you're only updating specific like the specific rows or the specific changes that were applied. Is there some fancy way that you could do that, or is there or do you just have to rerun the entire query every time?
So you're exactly right, Brian. That is what needs to happen is the materialized view needs to be updated in an incremental fashion. Just
Okay.
the change data needs to be updated. But what we have right now is a full refresh, what is called a full refresh, where every time a refresh materialized view command is issued, the entire query is recomputed and materialized view is populated. The incremental refresh, it can happen in multiple ways, and this is where, as I mentioned, the excitement and challenge comes in.
Yeah.
With Iceberg specifically, you can look at snapshot IDs, you can look at what files were added to the underlying table, how the partitioning of the base table and the materialized view aligns to figure out what exactly needs to be updated.
Hmm.
From Trino point of view, though, given all the other connectors, maybe the approach needs to be more general, where a row level refresh might be interesting, where you can track which rows were added to the base table, which rows were updated or deleted, and pick up those deltas and apply them to the materialized view.
Where would
It's a little more complicated
yeah.
to implement, but I think it's a more general approach.
Would you store that? I guess that information would have to be stored in whatever metastore, or because right now we're talking Hive metastore, but I know like theoretically we're, you know, Iceberg's brought up a whole lot of discussion around like maybe alternative metastore capabilities, and so you'd have to store that, I'm guessing, in Hive, currently Hive metastore, but maybe some other metastore that you're using depending on the connector.
That's right, and it could be a connector specific implementation, or we could think about a common way to represent this metadata.
And is there any clear?
Just to understand this, like, I mean, obviously going down incremental approaches and stuff is super complex potentially depending on the query. But I think even the totally naive approach of, well, whenever we refresh it, we just drop it and recreate it new and leave all the complexity of the underlying system is a totally workable solution depending on the use case, right? Like if you have something where your view is like for whatever is yesterday and before, well, you just run it every day at midnight and be done, right? Like, so there's lots of use cases that are possible and enabled by just a totally naive thing where you're like, well, we just drop it and create it new and leave the rest to it. It just gets tricky probably when the data is so much that creating that view and it takes a long time, right?
And Angeli, you also mentioned like you could do it per row, but you could also do it like per like different ways that you can slice the data up, right? Is there any other type of slice that, or you know, kind of horizontal or vertical slicing that you can do that kind of focus in on how to update that?
Yes, partitioning is one of those ways. But
Sure.
before I touch upon that, I wanted to expand on what Manfred said. It's exactly right that materialized views are really a nice mechanism for the user to create and cache their data and rely on the system to tell them whether this data is fresh or stale. So in typical shops, it's different teams that manage ETL. So asking the ETL team to do like, hey, do a C task for me, create this table for me. There is a bit of friction there, right? Materialized views really remove that friction because the power is with the end user. It's a simple create command. It's a simple refresh command.
Yep.
And refresh, even if it's a full refresh, will be a no op if underlying data has not changed. Since the materialized view was refreshed. So it really puts the power in the hands of the end user.
Yeah.
Now, going back to Brian's question on incremental refresh, one of the simpler things that can be done perhaps quickly, the implementation could be done perhaps quickly, is using partitioning. For example, Iceberg, Hive both support partitioning. Say if your base table is a sales table that gets populated, say, every night with the sales data for that particular day. So that table is partitioned on date. And materialized view maybe aggregates the sales data by region, but also by day. And materialized view could also be partitioned by date. Now it stands to reason that as data for a new day comes in, that's the only partition in materialized view that needs to be added or recomputed. rest of the previous day's worth of data is still fresh and it's still there. So essentially, the refresh work is reduced to just doing this incremental maintenance. And this is something probably can be built fairly quickly.
Yeah.
That's awesome. So what use cases did originally drive this at Netflix, and how is it like? Are you running this in production now? Did it are you rolling this out? How your users are liking it? How is that going?
So materialized views are, we're rolling it out in production. Some of our users are already using it. But before I talk about materialized views, I would like to take a step back and talk about views a little bit, because in a way, views form the basis for materialized views. So what we did at Netflix was we took this Trino views implementation. We added support for logical views in Iceberg connector. As I mentioned, most of our data is in Iceberg format. So that support was necessary. And another interesting thing at Netflix is we have two query engines. Trino is the widely adopted, most beloved query engine, and Spark is another, which is used by people to do some heavyweight ETL. So it's often the case that one team or one person would create views, tables, materialized views through Spark, and users would use it through Trino. So given this interoperable challenge, it was really important for us that any objects we create are, they can be created, dropped, read from both the engines. So we decided to store the metadata in JSON format in S3, and we use Iceberg library for that. So if you're familiar with how Iceberg stores its metadata, we did something similar for views, and we call it common views. So Hive Metastore has the view object, a materialized view object, depending on what type of view it is. And it essentially points to an S3 file that has detailed metadata. Now, this metadata, as you can imagine, for logical views is schema, who created it, what the definition looks like, and so on. Moreover, we could version this metadata so that, as you say, create or replace view, create or replace materialized view, you have the same object that's undergoing transformation. Maybe first create view just selected 3 columns, then you decided to add a few more columns. You can track that version history. If needed, you could go back and roll back to the version that you wanted. But what this allowed us to do is access the logical views as well as materialized views from both the engines. And that made it really interesting for our end users, because then they didn't have to stick to one engine to do their operations. They could switch easily back and forth. So just last week for fun, I checked how many views do we have, common views, and the number a couple weeks ago was 147,000 views.
Wow.
Oh,
Wow.
So apparently our users do like it. And some of them are pretty simple with A/B testing team, experimentation team. It's just filters on test ID. Some of them are a little more complex with date filters. Others are a lot more complex where the definition doesn't even fit on a screen and you're just scrolling. It's like, wow, you're doing this with views.
Yeah.
You know, it's a join with aggregation and bunch of complex case statements. So it's all kinds of cases.
And that works transparently in Spark and in Trino now for you.
That's right.
Wow.
That's awesome.
That's really cool.
Nice.
So, yeah, as I'm wondering, actually, that's such a high number. A good chunk of that has to be probably coming from, you know, some automated generated type of view system. So I'm wondering what proportion is like your direct Tableau users versus you know, kind of defining their own views and how many of those exist. But yeah, still such a incredible number, and the fact that you're maintaining all of that. Is that all? That's logical and materialized views?
These are just logical views. And
Okay.
the same users of logical views started saying, hey, it would be great if these logical views could be materialized. That's when we started looking at materialized views.
Because I'm wondering if...
Because they want them faster as usual, right?
Yeah,
That's right.
That's also going to duplicate, of course. it's going to duplicate the some of the data there. So I'm wondering if depending on how the size of that, maybe some other thing at that scale, you're going to have to maybe make some considerations to increase capacity there. So storage capacity, right. Very cool. And I'm sure, I'm thinking about this, but you guys have already thought through all of that. So.
That's amazing. So Martin, what's the future now with this? Like, this is awesome. In the Iceberg connector, and the Hive connector also has some stuff. What are we doing next? This is all exciting.
Yeah.
Well, I mean, the future is to like, as Angeli was saying, we started with a small use case that we wanted to try out and kind of start fleshing out the APIs and how it needs to work. The future is to be able to handle any type of materialized views, have the engine be able to reason about the materialized views, be able to potentially even take advantage of materialized views to speed up existing query or new queries. Like, for example, if you create a materialized view that says, I want to count some value group by date, and then you happen to run a query that happens to have that formulation inside the query plus a bunch of other things, we may say, well, that can be substituted with the result we pre-computed already in this materialized view, and then you avoid a bunch of computation at runtime.
Wow.
Is what's called materialized view query rewrites. Rewrite parts of the plan to take advantage of what you have already computed in a materialized view.
Wow.
So those are the things we're going to start looking into. I mean, it's a complex and complicated topic, especially in how an optimizer needs to work and all that. But
it's almost not a total substitute. It's not a total substitute, but it's almost like kind of similar to spilling to some degree. It's like, I mean, other than the reuse, there's a reuse part of it that wouldn't necessarily be just spilling it, but that could definitely be some sort of I guess way to avoid having to do any type of spilling if you pre-compute.
But it's much more native, right? Like, it goes to the underlying storage. So
yeah.
So now all of this work is currently happening in the Iceberg connector, and I guess some stuff exists in the Hive connector. Are we gonna see those sort of like merge so that like both views are supported in both connectors, and then we'll sort of sprinkle it out across other connectors? Is that kind of also something that people are looking at, or not just yet?
Well, there is an engine component to this, and that's common to every connector. So the smarts about how to interpret the views, how to do the rewrites based on the view definitions, all that happens in the engine, or will happen in the engine over time. And then it will be up to connectors to just implement the corresponding connector APIs to provide the view definitions, to provide the bits of information that the engine needs to be able to make those decisions, just like with any other connector API.
Is there any other connector? Okay.
No, I was going to say, and then over time, hopefully we'll expand support to other connectors. Like today, Hive and Iceberg are the main ones, but I expect other connectors to leverage this over in the future.
That was going to be my question, actually, was like, is there any other connector that we have in mind where this would be like, just a heads up to anybody who is in any kind of thing? Like, I'm trying to think of what this would look like in, like, let's say Elasticsearch. Is that even like possible to do something like this in Elasticsearch, or is this like, is there only specific kind of more traditional like SQL type databases that this would make sense in?
Well, I guess a longer term, given that the majority of the logic will exist in the engine. So the logic for how to process a materialized view, how to refresh a materialized view, how to potentially incrementally refresh the materialized view, how to rewrite a query to take advantage of a materialized view that already exists. Then the job of the connector will only be to store the definition of the materialized view and store the data. And then maybe there might be a few more APIs to be able to describe the incrementality of the definition and so on. But then it's up to, like, for example, in Elasticsearch, you may have an index that happens to be a materialization of a query over another index, or even a table in a different connector.
Yeah.
And then the engine will be the one that maintains the freshness and so on.
Got it. Yeah, so you could even have maybe have like your own one index that's actually storing the data, and then another index that would actually be storing the kind of metadata about like those refresh intervals and things like that.
You could do it that way, yeah.
Yeah. Cool. Okay. Well, that's really interesting and super cool. Is there, Anjali, is there anything else that you wanted to kind of cover in terms of like your work or in particular the what you all have going on in Netflix?
One interesting thing I wanted to mention was we are exploring use of materialized views for query result caching. So if so the idea is you use the same materialized view infrastructure. When the query first comes in, you create a materialized view that stores the data using in-memory connector or some other mechanism, but idea is to store those query results in memory so that when we see the query the second time, Trino can establish whether the cached results are still current, still fresh, and serve it from the cache. So that's something we are playing with, and
it's funny because like
excited about
we
it.
keep hearing about the memory connector. We were talking just last week with the Resurface guys that they were basically they had used some of their initial prototyping for their solution. They used the memory connector. So it would be kind of interesting to see if some of your work and their work would overlap in some way. Particularly making the memory connector something that's a little less, something more production durable. So
it's not in production yet, but from how we have played with memory connector, it looks like a very promising thing to use.
Cool. Yeah, that's so interesting to hear. I mean, so we even talked about a couple of the implementation details that were missing from it. Like, have you kind of made it a more distributed memory connector? Like, does it? Oh, wow, very cool. So you've already kind of etched into that. Anything else you could tell us about, like, kind of some cool things about the memory connector before we hop off that subject?
I think memory connector needs a few little improvements, but for example, spilling one is the one that comes to mind.
Yeah.
Being able to partition the memory tables, that would be super useful. But one of the use cases we are trying to support with memory connectors is where there is a flow where first query creates some intermediate results that reside in these in-memory tables. Subsequent part of the flow reads multiple times from these intermediate cached memory tables, and then create more memory tables, which in turn, in the end, gets read and returned to the client. So that's kind of the memory connector related. Another use case that comes to mind, that where we are exploring use of memory connector.
And you all jumped into memory connector because of like perhaps the more native the more native use of in-memory structures and things like that versus something like, we already have like a Redis connector, but that's kind of I guess going across an entire network and things like that to actually like this is something Rob was said that they avoided the Redis connector just because there's a whole network hop in between there that you're having to deal with versus maybe just directly storing it in memory in Trino.
That's right, and there is no serialization, deserialization happening with memory connector. It's the how the data is in memory is how it's stored and read. So reading from memory, writing to memory has to be the fastest thing you can do, rather than reading from S3 SSDs, any other mechanism.
I find it so fascinating that this is like something that keeps popping up. So definitely something to keep our eye on as well with this memory connector craze that's going on in the community. So thanks for bringing that up. So, well, with that, if nobody has anything else to add, I'd like to hop on. So, officially talk about this PR of the week, even though we've been talking about it before. So this was 4832, and this is the one that you had gone through and created, Anjali, and this is the one that actually pulled in the Iceberg connector for materialized views. If you want to check out, the changes that were involved, you can definitely go in and check this out. It's pretty interesting to look over some of the changes that were made, and just even to get a sense of the different tests that were run, just to kind of understand like what was involved to set that up. I also put in the honorable mention PRs. So you had a separate PR that was more focused on the syntax that needed to get added. So we had no syntax even for creating and refreshing and then dropping materialized views. So this in itself was yet another change that if you're more interested into the kind of parsing and syntax stuff, this is a cool PR to check out. Anything you wanted to mention about those like difficulties there, or something to if our users want to go jump into it, what are some of the cool classes or anything to check out there? Nothing on the top.
Nothing off the top of my head.
Okay.
Sorry.
No, that's fine. That's fine. I put you on the spot with that one, but yeah, definitely check those out. I think it was interesting to just take a look over those. And then the last one I wanted to do as an honorable mention was from Laura Chen Yu, and that was this integrating the Coral one. I mentioned that before. So this one was the actual PR 4661 that brought Coral in, that enabled us to read those Hive logical and Hive materialized views. So thank you very much for everybody who's contributing for all of these, so we can have such a pretty view from the from Trino.
Yeah, the Hive views, that's a lot of work involved. Piotr and others are like very much on that. It's a long process too. We're working very closely with them to improve Coral and like have more test cases and stuff like that. So that's an ongoing large effort. So lots of people involved there. It's great. Yeah,
we have to maybe dig into that more in another show. So finally, let me go through the demo real fast. So I'd like to actually show anybody who wants to get their hands dirty with this. I think it's just a lot of fun. I need to get a better setup for this, but what I'm currently running on is a temporary Docker image that's using this testing image that we have. Eventually, I will make a separate Docker image that will encapsulate basically HDFS and Hive in place of this. But for now, this is basically, you want to have some sort of Docker image that houses Hive sitting over HDFS, and then we will then have the Trino coordinator. And in the definition here, let me just show this for anybody that's curious to know. We expose the metastore from this image, which is just at 3306. The thrift API is at 9083, and then we can also talk directly to the Hive. So those are like the three super important ports that get exposed here. And this enables us to do a couple things. We can, obviously directly connect through Trino by specifying the thrift API or the thrift URL. We can directly connect to Hive, so we have a direct connection to talking directly to Hive, and then we can also look at our metastore. And this is actually, this metastore DB one is the one that we're interested in. So why don't we go ahead and start out? The first command we can run is, let's just see what schemas. I've labeled this. The catalog HDFS, but it's actually just a Hive catalog. And what we want to do is create a schema called Tiny. Let's go ahead and create that schema. And then we're going to actually create two tables. And this is going through Trino Hive connector just so I can easily run the CTAS query to pull data from the customer and orders tables and dump them into the Hive tables here. So we'll go ahead and run those. So this is first copying over customer. There we go. And then copying over orders. And now, as you would expect, we can just pull a little sample query from those. And I added the create table just so you can look at the schema. So off these two tables, if we now look in Hive, we now have a tiny database under the Hive one. So we created it in Trino, but now it shows up under Hive, and we still have those customer and orders table. So now let's first look at the legacy support. If we create a view in Hive using those values, first let's actually, let's go ahead and create that. Let's see. Oh, got an error, of course. Let me see. Nothing immediately. Oh, there's some issue in. We might have to forego messing with that. Let me try to just do one more refresh on the connection and see if we can run it one more time. Oh, okay. So see if we can use the tiny. I think I just needed to refresh it. It's thinking now. There we go. Use tiny, and now we want to. There we go. Created the view. Okay. So we created this Hive view, and now let's go ahead and take a look in the Metastore, what the status is. So we're basically going to look at the tables that we have set up under the tiny database in Hive. And what we see here is we see the customers table and we see the orders table, and those are of table type external table. Then we've now created a Hive view, which is a virtual view, and it shows the text that was created here. So this is when I was showing the sequence diagrams before. This is what ultimately Trino will go out and retrieve, and this is in the Hive syntax. So this is the part that will need to get translated through the Coral library before this actually gets sent back to Trino. Likewise, we can also create a materialized view in Hive, and I'm just going to do these together. And this is actually going to execute this query, actually run this select statement down here that before the before the view statement, and then actually store that in HDFS versus the exact same query that was run in this Hive underscore view table, or Hive underscore view is going to simply just store the SQL. So let's actually go ahead and now update the Metastore information, and the view origin view text, or basically the view query, is still the exact same between the two, the materialized view and the logical view, but the difference is within the table type. So Hive actually stores it as a virtual view versus a materialized view. So that's how Hive itself knows how to pull this data from there. And so now if we go to looking at this from Trino, we would now actually want to run this query against Trino and be able to talk to Hive. And let me just copy this select statement. So if we actually run on HDFS tiny, and if we look at what views are available, let me just refresh this real fast. We should see that Hive underscore view is available. And what's interesting here is that, here, let's pull Hive view underscore view. Let's pull that data back. So we now have data coming in from Hive. This is where the Coral translation had to happen in order for the planning to take place. And then we actually get our results from talking to the logical Hive view. So that didn't have any data actually written into HDFS. That actually ran the query at runtime and then pulled that data back. Now, if we wanted to run the materialized view here, we would say Hive underscore materialized view. And this is actually going to return a lot faster because it's actually just pulling back data that almost like it's pulling data from a table. So, but underneath Trino, it actually doesn't show underneath views. It's showing as, I thought it should actually show as a view. No, yeah, it'll show as a table. So this is kind of one of those things that Martin was talking about, where depending on how it's implemented in the connector, it will show maybe some views will actually end up showing. And I think this is how it's done in like Postgres and MySQL. It'll show views as actually showing up under tables. And that's just a small implementation detail, but you're still able to query it the same way nonetheless. So that's pulling Hive created views from Trino. Now, if we create a Trino view, let's go ahead and create a view from Trino and store it in the Trino syntax. So check what that looks like in Metastore and update that. We have Trino calls it a virtual view as in terms of the table type, just like Hive does. But then it actually stores an encrypted blob here, not encrypted, but just a byte blob of the query that will ultimately get pulled out and translated back directly to Trino. So there's no, in this particular case, there's no Coral translation that needs to happen here. So so if we run the query on the Trino view, we can, oh, I didn't select the right thing. There we go. Same thing, we pull the data back, and this time it's almost like the Hive view, except for the difference is that no translation needed to happen because it was stored as in the Trino syntax. If we look at the create view on the schema on this, you actually find that this is actually going to be showing you the internal view syntax that gets returned. It actually doesn't show the schema or show the types or anything like you would with a regular table. So that's specifically with a logical view. But materialized view is a little bit different. I also wanted to show very fast, in Hive, you are not able to actually create a materialized view. So we'll get an error back that says this connector does not support creating materialized views for now. And that's just something that is just to know if you're using the Hive connector, that's something that's not supported now. Now let's move into Iceberg and see if we can actually create a view on Iceberg. And in particular, the logical view, I'll just say right now, it does not support creating views. So you'll also get a similar type of exception there. But with Angelique's PR, we are able to now create materialized views in Iceberg. So if I go ahead and run that, it's actually running the query and going in and moving the data around and actually running it. So it took a little bit longer than just the quick view definition. And if we look at that inside the Hive Metastore, we now see two things come up. So Angelique, I think you'll explain this better than I can. What's going on here? Why did we create a table, external table, as well as a virtual view? Could you explain that a little bit?
The reason is the materialized view has a view definition, which is captured in the form of that virtual view object, and it creates a storage table where the data for the materialized view goes. That's why it has two representations in the Metastore. Cool.
Yeah, so it'll show up actually with a table name with kind of a bit of a cryptic table name there, but internally the Iceberg will store this directory or just direction into that to point to that external table in the metadata. And then so we can actually then pull from that data. It's Iceberg materialized view. We can query it just as before, and then the last thing I wanted to show in the difference between materialized view versus a what is it? Let's see, Iceberg. Here, I want to say Iceberg materialized view. The difference between the schema or the show create view that gets returned when you run this. That I show create. Oh, is it show create materialized view? Oh no, you can actually run show create table on the materialized view. That's what it was. So if you run show create table on the materialized view, or maybe that wasn't right. Is it show create materialized view?
You should be able to run show create materialized view.
Okay, maybe that's what it was. Oh, I thought I had done it. Show create materialized view. Oh, I have the wrong Iceberg. I think if I show Iceberg and use that, there it is. Okay, I was trying to call it from Hive, the Hive connector versus the Iceberg connector. So, and this one actually shows this one also shows the view. I think there was one way that I pulled it out before where it actually showed the table definition. And so I was getting a little confused there. So this is showing the correct view query versus showing the actual table schema definition. So,
So Brian, in your sequence, I do not see a refresh happening. Maybe
oh,
if you did a, yeah.
yeah. Now, if
So
I,
it likely expanded the materialized view to
this limit
run
10.
the select query.
Okay, so it would have expanded it, but it doesn't actually run the query in the very beginning. So let's go ahead and actually do that. That's a, so we would say refresh.
Materialized
Here,
view.
yeah. Let me just, and then we'll do that on here. And it's so if I actually did a before we actually run this, what if I do a count? If I did a count on the table that was generated here, just do a little. I should expect to see. So there's this ST table. If I actually did a count here, select count from, and then Hive or HDFS tiny dot, and then this ST value. Should I expect to only see like a, let's see what we get. Unable to create input from file input format.
I think a better way to see how that query got executed is to put an explain in front of your explain select star from materialized view.
Okay.
And that plan should show the use of the table, not the materialized view.
Gotcha. Okay.
Of the underlying table.
So let's do explain select star from, yep. And then we'll do iceberg. There we go. All right. Oop. I lost. Okay. So Rose down here is saying 15,172 coming from the source. So let me see. Then the scan. But I'm trying to see what actually comes up. So it looks like that actually did execute when I did the select. So the refresh would actually,
Do you see the table name at the bottom at the scan level?
The scan level. The scan level is showing there. It's going to be hard for people to see this on the setup here, but the table name here on the view.
So essentially, if you looked at this plan, it's right now not coming up clear for me.
Yeah.
Or in the UI, you would see that your materialized view was based on a different table. You would see that table getting accessed here.
Okay.
Now, if you refresh the materialized view and then did a select or explain at the scan level, you would see the storage table name.
Okay.
The cryptic name.
We'll leave.
That's how I would tell whether we are serving cached results or if we are expanding the materialized view.
Okay, that'll be a good, I think, follow-up exercise for anybody who's playing around with this, so we're not hanging too long. But yeah, I think that's definitely something that'll be cool to play around with. So ideally, they would see, are they pulling this from the ST underscore, some sort of actual staged table, or is this actually coming from some sort of expanded, like, logical type view?
That's right.
Pulling from that. Okay, cool. So now let's run that refresh materialized view. And cross connector materialized views are not supported. And this is pulling from Iceberg, tiny Iceberg materialized view. Okay, well, we'll leave that. I'll put something in the show notes and see if I can fix that up afterwards, but and see what, there could be something wrong with my setup in terms of running this, but it's saying, yeah, cross connector materialized views are not supported. And maybe, unless there's something immediate you have that came to mind.
Does your view refer to a table in a different connector?
Table in a different connector. So maybe I need to do this in HDFS. Let me see. Let's try HDFS tiny. But I would imagine it would have been, yeah, okay. It's going to be under Iceberg, I would believe. I'm wondering if...
Well, you have to look at the view definition.
Oh, okay. Well, let me see. Where are we at on time? We're already at about an hour 20. I would say I'll take a look at this after. I'll take a look at this afterwards, and then we'll add the issue in the show notes, and then potentially look at what would, if you do get this error when you're playing around with it, what you can do in place of it.
So one, like Martin mentioned, currently the materialized views are supported only in Iceberg. That means the table needs to be Iceberg, and the materialized view that you create has to be created through Iceberg connector. And I think that is where
That
the
might have been
disconnect
the issue.
is. But Brian, you are a very brave person to be doing online on the spot demos. So kudos to you.
Thanks.
By the way, that's also interesting to note, by the way, which is kind of really odd. The logical views in Hive can refer to whatever. Like you can literally use the Hive. You can create a view in Hive, in the Hive connector, that doesn't even point to a table in Hive. It could be some other connector, or like do a federated query that pulls various things together, which is kind of an odd use case. But because the query of that view definition is just transparently stored as a string in the Hive meta store, it doesn't really matter what's in that view in the definition, which is interesting as a use case.
Yeah, I don't know if I grepped all that. I grokked all that what you just said, but yeah, let's go ahead and move on to the onto the question of the week, and we can wrap it up after that. Let's see. So question of the week, are JDBC drivers backwards compatible with older Trino versions? So this gets into one of the questions that came up a lot whenever we did the name rebranding from PrestoSQL to Trino. And so I'll kind of go in the full question. It's actually, are they backwards compatible with older Trino versions? Currently trying to install a 354 driver on multi-tenanted Tableau server. And so there might be older Trino versions at play. So sounds like they have a mixed bag of, sometimes they might have a PrestoSQL before, like lower, less than or equal to 350 client, and then they may also have a couple newer Trino clients. And so in this particular use case, provided they are using a Trino server, they would actually be fine because Trino basically. Trino is able to handle both the Presto header and the Trino header coming from both of those clients. But if they were on a older, PrestoSQL server, and this is something that wasn't really specified in the initial question, but if they were running on an older PrestoSQL server, then the Trino clients wouldn't be able to actually talk to the 350 and below versions of Trino as well. So I like to kind of summarize it as, in short, you can have a PrestoSQL client talk to a Trino server, but you can't have a Trino client talk to a PrestoSQL server. That's kind of the general summation of the answer there.
The recommendation is to upgrade both to the latest releases or later newer Trino releases to get cool commands like match recognize and all sorts of new features all the time.
Oh, speaking of match recognize, we'll do one last little talk about this. Martin, I think you were the closest to some of the changes going on with Kaisa. So would you want to kind of talk about what is match recognize and what does it do?
Cool, that's a topic for an entire hour. Take a look at that blog post. But basically, in a nutshell, it's a SQL language feature that was added in the 2016 revision of the SQL specification. And what it allows you to do is define write queries that can find patterns in your rows. So you can say, I want to match. That normally in SQL you can operate on single rows, so you can do full aggregations of rows. With window functions, you can sort of do some kind of processing across multiple rows. Mm-hmm. With match recognize, you can say, I want to see sequences of rows that follow this pattern.
Wow.
And the canonical example is like you have, prices, and you want to see when the price goes up and down and up and down and detect that pattern. And then you can do something with it. You can you can like capture the peaks and the valleys, and or the highest price or the lowest price or something like that. And this is something that is very, very hard to do without this type of feature. So it's a very sophisticated feature, very complex in terms of all the things you can do. So I would encourage, go look at that blog post and then try it out.
Awesome.
Yeah, props to Cassia. She wrote the code, she wrote the documentation, and she wrote the blog post, and we just helped her. But oh my God, it's pretty amazing.
It was fantastic work. This is a complicated language feature that touched everything from the language to the execution engine. So optimizers, analyzer, parser, and the code. And just trying to decipher what the specification says is a huge task. It was a 14,000 line change.
Wow,
so that's a pretty massive change.
That's insane. I think she's trying to push her way up into the ranks of the top 10, I guess. So
I think she's already there.
Yeah, she I wouldn't be surprised. So very cool. Well, that's a cool way to end it off. Anjali, thank you so much for joining us today to talk about all this cool stuff that you have been working on, and just stuff that's been going on at Netflix in general. We've had Netflix on now twice, and just each time we just get to hear about just really, really cool stuff that you all are doing over there, and really happy that you all are sharing it with us, just talking about what you're doing instead of just keeping it all internal.
Exactly.
My pleasure. Thank you for inviting me.
Okay. Well, with that, thanks everyone for joining. And we'll be taking a little bit of a 3-week hiatus after this. We kind of moved this week a little earlier because I have family things coming up in the next couple of days. I'll be moving here shortly. So thanks for bearing with us on that. We'll be off for 3 weeks, and then we'll be back as ready as ever to talk about the next cool Trino feature and see what's going on in the community and all. So
definitely 357 and maybe even 358, right?
Maybe.
Like, who knows?
Yeah, we had to skip the 357 release because that will be coming out probably landing tomorrow or the day after. Is that right, Martin?
Yeah, today or tomorrow.
Okay. Yeah. All right. Well, thanks everyone for joining us. Music for the show today is from Mega Man 6 gameplay album by Krzysztof Slawikowski, and you all have a great day.